Rahim. In today's video lecture, we solve the question number 4 of problem set 14.1, and this is our question. And in here, the real and imaginary parts are already separated because this is real part and this is imaginary part. So we know that in general form of a complex number is x of t plus iota y of t. So this is our equation number 1 and this is our equation number 2, and comparing 1 and 2, comparing equation 1 and 2, we get x of t is equal to t and y of t is equal to 1 minus t whole square. So this is the parametric equations of our curve, and we remove this t or eliminate this t from both equations, then we get the relation of x and y. So y is function of x as in calculus. Conventionally we know that. So we get the equation of our curve. So eliminate t here, eliminate t here, and t is the parameter, so we eliminate the parameter here. So x is equal to t, so we put here y is equal to 1 minus x whole square. So this is the equation of parabola, because we know that this is a general equation of parabola. We know that y is equal to x square is the parabola. So in here this is the shifted parabola. So this is shifted parabola. So this is shifted parabola. This is shifted parabola. And shift in x. So we shift in x-axis. So this parabola shifted along the x-axis. If shifted in y, then this become y plus k or y plus 2. Then this shift in along the horizontal, along the vertical, but this shift is along the horizontal axis, so x-axis. So now we find the starting and ending point of our curve. This is decided, this is shifted parabola. Before draw the geometry of this shifted parabola, we first find the starting and ending point of our curve. So starting point is, so how to get the starting point? Starting point from here, t is minus 1. So t is minus 1 put here. So x is equal to minus 1 and y is equal to, this become 1 minus 1 whole square this is equal to 4. The starting point is minus 1 and 4. Now we find the ending point of our curve. So what is the ending point? At t is equal to 1. So put here x is equal to 1 and y is equal to 0. So 1 0, x is 1 and y is 0 is the ending point of our curve. Now we sketch this parabola and mention the starting and ending point of here. So this is our x-axis, this is our imaginary axis, this is x negative and this is iota y prime. So this is if this curve is y is equal to x square, like this is y is equal to, it means a parabola passing to the origin. So the curve of this parabola is this is okay, and this is passing to the origin 0 0. But our parabola is shifted, and and shifting along the x-axis, because a shift along the change in x. So first we check the shift in right side of x-axis or left side of x-axis. So for this we just put 1 minus x is equal to 0, and this become x is equal to 1. So it's mean x is equal to 1 mean this parabola shifting along the right side. So let's suppose this is 1, and this is 1. So our this parabola y is equal to x square shift along right side. So this become, yes, so this is our parabola. So it's ending, and this is just sketch. We also check the starting and ending point. So starting point is -1 and 4, x is -1 and y is 4. This parabola is also in the second quadrant, because x at x -1, y is equal to 4. So we put the point here. This is our, we just shift the axes, and okay, we draw the new one. So let's suppose this is 1, and this is our parabola passing through here. So this is x is equal to 1. Okay, at x is equal to 1, at x is equal to -1, y is equal to 4. In here x is equal to -1, and in here let's suppose y is equal to 4. So this is our point -1 and 4, and the next point is 1, 0. Ending point is at x is equal to 1, y is equal to 0. So this point is 1, 0. So between these 2 points is our path. So this is our path. 2 point is this is just sketching of our plane curve. So now we move on to the next question, and that is question number 5. Problem set 14.1, question number 5. So in here we first separate our real and imaginary part. So this is z of t, and this is equal to 2 minus 2 iota plus root 5, and this is e की power minus iota 5, and we use the Euler formula here. So this is equal to cos of minus t plus iota sine of minus t, and this becomes 2 minus 2 iota plus root 5, and cos is even function, so this minus are omitted. So this is equal to cos t, and sine is odd function, and this is outside the function, and this is minus iota sine of t. So we separate the real and imaginary terms are here. So how to separate the real or imaginary terms? So this is 2 plus root 5 cos t plus iota, and this is minus 2 minus root 5 sine t, and this is the imaginary part, and t is complete circle. T is 0 to 2 pi. So first we separate the real and imaginary part of our z of t. Now we know that z of t is equal to x of t plus iota y of t, and this is our equation 1, and this is our equation number 2. And separate or comparing 1 and 2, we get, comparing equation 1 and 2, we get what we get. X of t is equal to 2 plus root 5 cos t, and y of t is equal to minus 2 minus root 5 sine t. So these are two parametric equations, and we get the original geometry of curve if we remove the parameter t. So the next step is we remove the parameter t. So in here we remove the parameter t, and how to remove the parameter t? By using or with the aid of trigonometric identity. So if we write this is x minus 2 is equal to root 5 cos t, and this is equal to y plus 2 is equal to minus root 5 sine t, and squaring and adding. So first we squaring x minus 2 whole square, and this become 5 cos square t, and square here y plus 2 whole square, and this become 5 sine square t. Now adding these two equations, we get x minus 2 whole square plus y plus 2 whole square, and taking the 5 common here, and cos square t plus sine square t, and this is x minus 2 square plus y plus 2 square is equal to 5, and this term become 1. So what is this? This is the equation of circle. This is the equation of circle, but shifted circle. This is shifted circle. Shifted circle mean this circle not passing to the origin. And what is the its center of this circle? So center of this circle is very simple. Just put x minus 2 is equal to 0 and y plus 2 is equal to 0. In here x is equal to 2 and in here y is equal to minus 2. So 2 minus 2 is the center of our circle, our shifted circle. Okay. So now we checking the ending and starting point. So how to check the starting and ending point? So this is the complete circle 0 to 2 pi. So we now need to put the value in here x0 and x0. So check starting point. So x is equal to at t is equal to 0, so x become at t is equal to 0, this become 2 plus t01, so this become 2 plus root 5, and y is equal to minus 2. Now ending point at t is equal to 2 pi. So put here x is equal to what is the value of cos 2 pi? I think cos 2 pi is 1. So this again become 2 plus root 5, and y sin 2 pi I think 0. So this become y is equal to again minus 2. So this is the starting and ending point. Now we draw the path of our curve, and this is so simple. This is so simple, and we note that in here x is positive and y is negative, and in which quadrant x is positive and y is negative. So we draw the sketch of our curve. So first we put the center x along x is equal to 2y. So in here x is equal to, in here y is equal to minus 2. So this is our point. This is the center of our circle. So path is I think 0 to 2 pi is here, so no need to do this. This is complete circle 0 to 2 pi, so no need to check the starting and ending point are, because starting and ending point are same. It means this is a complete circle, because in complete circle starting and ending point are same. So we just draw the circle here. So this is our circle. This is our circle, and whose center is 2 and minus 2, and this is the shifted circle. This is the shifted circle, and in here why we are not going to in this quadrant, because we are just in this quadrant, because x is positive and y is negative. So this is our circle, and this is the sketch of our path. So now we do question number 6. Thank you. Question number 6, again we find the path. So we just write the Euler formula here, and this is equal to yes, this is equal to cos minus pi t plus iota sine minus pi t. Okay, so this is equal to z of t and 1 plus iota plus, and we know Now let us start with question number 9. So in question number 9, again same step are performed here. So we first separate the real and imaginary parts, and this is already real and imaginary part are separated. So we comparing this equation to this equation, x plus iota y. So x is equal to t and y is equal to 1 minus t whole cube. So if we put the t here, so become y is equal to 1 minus x whole cube. So this is the cubic equation and this is the cubic function, and we know that the y is equal to x cube, and this is the cubic function, and the graph of this function is like this. So this is the graph of y is equal to, we know that from the calculus. So if 1 minus x, so for 1 minus x is equal to 0, the x is equal to 1. So it's mean shifted in the right side, and the graph of this function is like this. So this is the path, and we just find the starting and ending point of the path. So at t is equal to -2 is the starting point. So put here t is equal to -2, so this become x is equal to -2, and y is equal to put -2 here, -2 here, -2 here, and 1 minus -2 whole cube, and 1 plus 2 3, 3 power 3 is equal to I think 27. So -2 27, and ending point is at t is equal to 2. This again become x is equal to 2, and y is equal to I think 1 minus 2 cube minus 1 ka cube minus 1. So this is -2 27, and this is 2 minus 1. So at x is equal to -2, y is equal to 27. So we just draw x minus 1 equal to 0, 1 minus x is equal to 0, and 1 is equal to x. Okay, we just take like this, x minus 1 is equal to 0 and x is equal to 1. If x is equal to 1, this is move right side. Okay, so this become okay. So this is mathematically not possible. So I think this our path is wrong. So I check from book. This is basically a function z of t is equal to t plus iota t cube. So this is our right question. So this question is wrong, because if we shifted at right side, so how we touch with at x is equal to -2, because we x is equal to -2 is here. So I think this question is at x equal to -2, y is equal to 27. So maybe this is -2, and but how this is -2 27 is up. So our so this question is wrong. So this question is wrong. This is mathematically wrong. It is not possible to put the point -2 27 here. So this is the right question, and please students solve according to the this equation. So now we go to the question number 10, and question number 10 is we just write up the question number 10, and this is equal to z of t is equal to 2 cos t plus iota sin t, and t is 0 to 2 pi. So this is so simple. Okay, so now we want to find the solution of this. Real and imaginary part are separated. So x is equal to 2 cos t, and y is equal to sin t. So this is simple. If the 2 here, so this is the equation of circle, but in here this is 2 and this is 1, so this is the equation of ellipse. So how to solve this? This is x by 2 cos t, and this is y is equal to sin t. Squaring and adding, then this become x square over 4 plus y square over 1, and this is equal to cos square t plus sin square t. This is equal to x square over 4 plus y square over 1 is equal to 1. So this is the equation of ellipse. This is the ellipse, and this is major axis and this is a minor axis. And we also write this x square over 2 square plus y square over 1 square is equal to 1. So a starting and ending point. So at t is equal to 0, x is equal to 2 and y is equal to 0. So point is 2 0 and t is equal to 2 pi. X is equal to 2 and I think cos 2 pi is minus 1. Cos pi is minus 1. So I believe, please check this. I think this is minus 2 0. Check the value of cos 2 pi and cos pi plus pi. Okay, so this is basically ellipse, and we sketch the graph of this. So this is basically 4 points, and we draw the ellipse like this. So this is my geometry is not so good. So this is slip. This is ellipse like this. This is like egg shape like this. This is ellipse. So this is a sketch of the our curve. So problem set 14.1 is complete. So in the next video lecture we start the another problem set of this KREYSZIG book. Thank you very much.